bodies. So I encourage people not to make your life too hard and create an actual body shape. So if we wanted to, we could create a table called, we could call it body shape, and then include it as shape equals and whatever the table was, and that table would contain a series of vertices, positions X, Y, X, Y.
I'm glad you're saying this, Ed, because I've messed with that in the past, and as you said, trying to understand the unwindings, and it's just it's a pain, and you could obviously use a primitive shape like a circle or a square, but then you kind of feel like maybe you're not doing it right, because you're like, well, I have an ability to do all these other more fine-grained things. Maybe that's exactly the way I should be doing it.
People feel like, well, because the feature's there, I have to use it. No. The other thing is circles are best because they are the fastest. You got to think about what the physics engine is doing on the underneath. Underneath, it's doing a calculation that says, was there a collision? Was there a collision? The simplest collision calculation is the radius calculation, or a diameter, if you want to look at it that way. Simply saying, is the center of this object within a certain distance of another object? And it's a little more complicated than that. I'm under-explaining it a bit. But the point is circle-to-circle collisions are the simplest calculation you can do. It's simply a distance calculation. Once you get a square or a triangle or a quadrilateral, whatever it is. Well, quadrilateral is a square. Sorry. It's a rectangle, is it not? Anyways, correct me if I'm wrong, Stephen. Steve's probably like, Ed, you're doing that wrong. The point is...
Four sides.
Four sides, yeah. So it's a rectangle. Well, it doesn't have to be a rectangle because it doesn't have to be parallel to each other. That's right. Quadrilaterals the sides are not necessarily parallel. Okay, anyways, the point is, once you graduate... Charles is laughing. Once you graduate to a vertices-based body, the calculations go through the roof. Now we're talking about calculus. And calculus is way more expensive than doing geometric calculations. They're geometrically more expensive. No, literally. I mean, these numbers are not entirely accurate, but if a circle calculation is a 1, a triangle is going to be probably start off at 4 times as expensive, and then a square is twice as expensive as that, and it just goes up every time you add a vertices. So not quite. That's not exactly right, but it's quite expensive. So long story short, get by with a circle body, or if you can't, get by with the simplest body you can, either a triangle or a rectangle.
Well, and in general, that's probably a good practice in general, right? Don't overcomplicate something until you have a reason to do so.
Yeah, it's going to make your code harder to understand, and it's going to make your game slower. Stop doing the help. I don't need help. I'm not trying to get help for folks. This thing is, I really love it because, I got to tell you, Zero Brain is actually pretty cool because I didn't tell it, it just knew where to look, and it gets all this stuff. It tells you all these cool things, like here's telling you about the filter, etc. So it's like, yeah, that's pretty cool. So, okay, so we're using my collision calculator, which is another plugin you can get, and what it lets you do is instead of making your life hard and having to do math calculations, you set up all your collision metrics calculations using names. And so if we look briefly, I know I'm running us out of time here. We did this last week, but if we look briefly at common, which is where I set up the calculator, the rules are very simple. I created, first thing I created a new calculator, and then I said, these are the kinds of objects that will be colliding. We have a player type, enemy type, player bullet, enemy bullet, and other. And I figured, that's enough things. If I need to add more types, I'll add them later. Then I set up the basic rules. I said the player collides with enemies and enemy bullets. And then at that point, then I said enemy collides with player and player bullets, and other, I'm just going to guess, collides with the player bullet, and the enemy bullet, but not the enemies. Maybe. I don't know. I haven't used it yet. But the point is, I didn't do any math, and now all my filters are set up. I don't have to go 1 plus 6, 7. Is my mask bit 7 or is it 9? I can't remember. You know, and then if you change it, and then you got to go back and do all your calculations. No, you know what? If I needed a Bob type, Bob, and I needed the player to collide with the Bob type, done. 2 seconds of typing, 5 seconds if you're slow like me on the show. No additional calculations. All the math is done for you. It's guaranteed to work. Done. So I get people in the forums all the time doing these, and I say, use my collision calculator. And I say, oh, I don't understand it. No, it's really simple, man. Get with it. Do it. You can do it. I shouldn't talk like that. Yeah, I don't understand.
Get with it, man. Get with it.
Get with the program, man. No, really. I understand. It's one more layer of learning. So, but in this case, you're saving yourself learning. You don't learn about it in this case if you don't need to. Boy, by which I mean the calculations. All right, so let me skip over some of this. Thinking. Let's go right into the movement because that's what we care about. So what I did for movement was very similar to what I did in the example we just looked at. I set up a key listener, and then if the A or left key, the D or right key, so you can use the WASD keys or the arrow keys on your keyboard. If those are pressed, I do some kind of calculation. And what that calculation is I add a value to move X and move Y, which are variables on our player that I initialized up here. And I'm not moving the player directly. Not like in the example where I move it to the left by 10 pixels or the right by 10 pixels. I'm using physics. So what I'm doing is when the player hits the key, I track that they hit the key, and I add that to a variable that the player has attached to it. And then down here, I have an enter frame listener. And the enter frame listener basically says, was there a change to the player's move variables? Where is it? Oh, sorry. Here it is. Was there a change to the move Y? Because you can only move in the Y direction. I'm ignoring all the other keys. So this code is actually going to get simpler. Originally, we can move left, right, up, and down. But now we only move forward. So the W key and the up key are the only ones that make you move. And you move in the direction, not running it. And then I'll let us go after this because I always run us over. Yeah, I move in the... Hello? Okay. Knuckles. What's going on here? Okay, I've broken the code. Good job. I have done something. Okay. Stack Overflow. Sorry. It must be Bob. Is Bob in here? Bob, are you in here? Okay, I've broken the code, doggone it. But the point is, enter frame listener looks for changes on those variables, and we do some calculations. We're just not going to have time to do them this week, but I think we should stop because this is complicated.
Okay.
In a nutshell, what it does is it looks in the direction. It says what direction is the player facing, generate a vector, scale the vector, and then apply that as set linear velocity. So if you're going to look at this week, that's what this code above here did. Am I moving forward? Is the Y different? Has it been changed? What direction is it facing? Turn that direction into a vector, and then scale the vector by the speed at which the player moves. In other words, if this value here is higher, this vector is going to be longer, and then apply that as the linear velocity. In other words, set the linear velocity of the player so that it's moving at a fixed rate. Linear velocity is saying a body is moving at a fixed rate. And from